So I created this video in response to things I was seeing in the lab, and it was something that really fascinated me, and I don't know if it's just because it's been so long since I didn't know chemistry, or students just aren't thinking about the problem, but I thought I might be fair and just try to present this video as a way to help bridge the gap. We talk about a lot of theory in our courses, but we don't really do hands-on stuff until we go to the lab, and I think students kind of make this disconnect that the theory and the hard experiment stuff are different, and they're not. So what I noticed is that students were doing, they were working with things, and they were asking things like, well, I've got a 1 molar HCl solution, 1 molar sodium hydroxide solution, where does the water come from? Okay, sodium hydroxide is a solid, and HCl is a gas. Why do you have a bottle of liquid? And I think the disconnect here is when you work with the molarity formula, you get M equals N over V. And I ask you, how many grams need to be dissolved in order to make the solution? Or they see the 1 molar like, oh, it's just 1 molar sodium chloride. The only thing that's in there is sodium chloride. Well, here's the thing. When you make a solution, think about what you're doing. So in the case of a 1 molar calcium chloride solution, I've got calcium chloride in this flask. Calcium chloride is just a solid. That's it. So how do I get it up to 100 mLs in this case? And the answer is water. And this is why when you see the molarity formula, it's moles of solute per volume of solution, not solute. Your solute is what you're dissolving, and that's what's in here is what we're dissolving. The concentration of calcium chloride as a solid never changes. So if you see a concentration written for something like 1 molar, 12 molar, 10 molar, 3 molar, that means that there's a certain amount of this solid dissolved in water or dissolved in some solvent. So more generally, there's all types of solvents, but most commonly you're going to be working with water. So if you see molarity associated with a concentration of something, the solution is not pure whatever that compound is. And so this was meant to be a 1 molar calcium chloride solution. This is all the mass it takes to make that. This is not 100 milliliters of calcium chloride you're working with. To make the solution itself, when you see that molarity, it means there's been a lot of water added to it to put it in water. And that's how we actually make the solution. That mass you see when you figure out the mass you need to make that molarity, it's definitely less than the volume you're working with. The remaining volume is associated with the solvent, in most cases, water.